Who in here has ever been to an airport? Okay, do not. Okay. Who in here knows what a web application firewall is? Okay, almost everybody. Who in here has actually had to do anything with the web application firewall before? Awesome, most of you. Perfect. My name is Jörg. I work for Ewald in Zurich. I'm the head of product management there for the web application security group. I'm basically responsible for the development of our web application firewall. It's called Airlock. And what I'm going to talk to you about is a little bit of a vision we developed over the last few years, how the web application firewall could be used for much more than they're usually used these days. When we look back at the early days of airline travel in the 1930s, security was pretty lax, I'd say. I mean, there's a fence there, an open gate, an open door. Gates were actually really gates at that point. And I think the only thing I can find on this picture that looks a little bit like security is the pilot checking tickets before passengers get on board of the plane. That's pretty much the situation we saw in the early days of the internet in terms of security, where we had a web application, we put the servers there, probably we put two of them there, so we had some redundancy. Then we have a firewall, and then there's the internet, and all the way to the client, no protection at all. Now, why is this a problem? Firewall protects the network, but not the application. All the traffic that's directed at the application directly can go through the firewall right away, because the gate is open. That's what it's supposed to be. It's supposed to be reachable. So anything that's directed directly at the web application can go through. One really recent example for where this really was a problem is Sony. You probably heard about how Sony lost a couple million data records, including credit card information. Well, they didn't have anything between their firewall and their application service. I remember very well the first time I visited Zurich Airport. I was 6 years old, and we stood on the visitors terrace. There were those huge planes in front. Zurich didn't have finger dogs at that time, so everybody boarding a plane still had to walk over the tarmac. But what I remember most distinctly are those piranha armored trucks there, those tanks. I didn't, as a kid, didn't quite understand what they're doing there. Everybody told me it's for security, so I was, okay, it's for security. I still don't understand how they can provide security by driving around tanks, around airplanes, but that's what one did at those days. Taking the picture from before one step further, what basically everybody does today is we add a web application firewall, a reverse proxy to the scenario we had before. What this does is, first of all, we don't have a direct connection anymore between the client and the web application. There's something in between, and that in between can first of all make sure that the protocols talked between the client and the web application is correct, and we can do some filtering. The easiest form of filtering is if we know how an attack looks, we can look at everything coming by. If it looks like an attack, we block it. Blacklist filtering. It's very easy to do. A little bit more sophisticated, if we know all the things that we want to allow, so-called whitelist filtering, we can let that go through. One way to do that is, for instance, you encrypt every URL you send out, and you only allow encrypted URLs coming back. Anybody coming to you with a URL that's not encrypted, it's probably not from you, it's not legal, go away. Another way would be to not even hand out cookies. We store the cookies on the web application firewall for all the sessions that are going on. Cookies don't go out, so they can't be compromised. In this scenario, basically we have the web application firewall doing one thing, the filtering, protocol break, and on the other hand, the application doing all its things, probably including authentication. So what we end up with are two islands of security who don't talk to each other apart from the actual data stream. But other than that, everybody takes care of their own thing and not much else happens. Airports today are pretty darn complex systems. In terms of traffic going on there, in terms of people walking around, doing their stuff, in terms of security requirements and security measures, it's gigantic. And it all works, at least most of the time. And the way it works, or the reason why it works, is because all the individual components which are responsible for it to work, they collaborate, they communicate. Everybody knows what they need to do and they pass information on back and forth. And that's where our vision comes into play. Our vision for tomorrow, where we say security shouldn't be the individual efforts of the application, of the web application firewall and all those. They should all work together. So we create a system that as a whole is a secure system. It's much more secure than if you started out with the individual bits and pieces. There's a lot of stuff on this slide and we're going to dive into it a little bit more in detail and look at the individual pieces. First, let's start out with authentication. If we remember in the 1930s, people walk on the airplane and they have their tickets checked there. Imagine today you walk on an airplane, somebody comes, sorry sir, can I see your ticket? Oh, I don't have one, I'm just looking around. Probably doesn't work that way. So airports, they check your authenticity, your identity right at the beginning. Are you a passenger? Are you a visitor? Are you just there to look? Do you work there? And if you work there, you work up in the tower, or do you sell flowers out down in the floor? So it should happen as early as possible. That's what you can do if you put a system like this in place. So rather than sending traffic right to the web application and you deal with this user and find out whether he's allowed to use you or not, when the request comes first and we don't know the user, we send them to an authentication service. And that one probably has attached to it one or several user directories and can figure out who is it. Is it the person they say they are? However do you want to do that? You can RSA token, password or whatever. Somehow you find out if it's the right person. Once the identity is established, you can assign roles to that person and allow them access to the different applications. And depending on who they are and what roles they have, you can give them access as a user to one application and as an administrator to another. You call this upstream authentication, do the authentication as early as possible, basically at the entrance, so once they're in, they can do what they're allowed to do, and all the applications, they don't need to care anymore about who it is that they're allowed to be there at all. My favorite part about airline travel, security checks. Security checks are basically gigantic filter machines. Everything goes through, everything gets checked, and some of the things don't pass through, like for instance if you have a little bit of water with you, that gets filtered out. Filtering is a big part of web application firewalls. As I explained to you before, standard procedure in every web application firewall is there's blacklist filtering. We know how a SQL injection looks. If that's one, we don't let it pass. Or whitelist filtering, where we say, well, everything that comes along this or that way, we let it pass. If you have more structured content, like XML, SOAP, or if you have a Flash application where data is transported back and forth using AMF, you know much more in detail what kind of data to expect. So at that point, you can use filters. In our case, they're external modules, but you combine them right along with it, where you provide the schema, and we check it. We check the data towards that schema, which provides a far more powerful way of filtering the content and even modifying if you need to. If If that's not enough for you, say you have additional requirements to filter your content, you write your own. There's a protocol that allows you to do this. It's called ICAP. It's a very powerful protocol to send data streams, HTTP streams back and forth. Check them, modify them, send them back. Another use for that protocol would be malware scanners. Imagine you have a website where people upload their files. Well, you want to make sure once they arrive on your server, they're free of any malware, of any viruses. So before they even go to the application server, they're checked for malware on one of those ICAP servers and then passed on or blocked if they're not clean. As I say, ICAP is a protocol that enables us to do this. It's been around, it's a standard, and it works both ways. So it works for incoming traffic as well as for outgoing traffic. When you go to the airport, one of the first things is you check in. If you want to take a flight, of course, you check in, you get a boarding pass. The boarding pass is basically a token that allows you and all the people you encounter on your way through the airport to direct you in the right direction. It contains information that helps you route your way through the airport. It controls the workflow, one could say. We got something similar going on. Now, imagine it in the classical scenario where somebody puts a web application firewall in place. That one's operated by the network people. Network people create rules, they change the rules a little bit, they help until it works with a specific application. Now, the network people don't really know what's happening with the application. That would be the application developers. But application developers don't get access to the security equipment, to the web application firewall or all that. So there's a gap in between. The declarative whitelisting is a way to bridge that gap. Rather than the system administrator defining filters and not really knowing whether that helps the application or not, the developers can actually say for each field they put out in forms what kind of content they expect back. So let's look at it. Very, very simple, easy example. Imagine an application puts out a form where somebody puts a PIN code in. Normally that would go out, somebody fills it in, comes back, and the first one to check whether this content is correct or not would be the application itself. Now, imagine if the application were able to pass along additional information like this is valid content for the field. The web application firewall would take note of that additional information. For now, not do anything with it, just, yeah, okay, we know about it now, pass the form out. The client fills it in, the person sitting in front of the client, and sends it back. And now, the web application firewall already is able to do the check. Without even bothering the application itself, it can see, well, 4711, okay, that's 4 to 8 characters, correct. It's 0s to 9s, yeah, check. We pass it on to the application. If somebody tried something sneaky like giving an invalid input, which may well be part of an attack, we check it again. Yeah, it's 4 to 8 characters, but it's not only 0s to 9s. Deny it, go away. Web application didn't even know about this. This is what we call declarative whitelisting, where the application passes information about valid input to the web application firewall and then doesn't even need to bother. Everything that comes back to it, it can trust that it is the kind of input it is expecting. One thing airports are really good at is guiding you through the whole system. I mean, they're usually pretty confusing mazes, but still in the end you end up in the right place. I've seen, in movie theaters, I've seen it several times that people manage to get out of one movie once it's done and get into another movie and watch that one. I really doubt you'd be able to do that with an airplane. Fly to Munich first and then sneak out of the airplane and get on another one to Paris. There's too many fences, barriers, and clear ways. It's only that way you can go and no other way. On the other hand, one thing I really like about airports, there's everywhere there's this friendly staff that helps you if you're lost, if you don't know where your connecting flight is, they can call on the radio and figure out where you need to go. We can do something similar. First, the fences and the directing you around. Hardened browsers are one way of ensuring that people only do the things they're allowed to do. It's a concept that's gaining more and more popularity, where the idea is, rather than letting people use their browser that's installed on their computer, we give them a browser where we know it's secure, it's safe. There's two ways to do that. Either you hand them out on a memory stick, and every time they put the memory stick in the machine, the browser gets started up and they use that one. And because the memory stick is read-only, it can't be compromised. Or you force download the hardened browser on demand as the person accesses a protected website. Those are, for us, they are third-party products. We integrated with both kinds. I'm going to show you the second one a little bit more in detail. So imagine you have a website where you say, well, everybody who wants to access that can only do so through a browser that we trust, through our own hardened browser. So when a client asks for the first page on that application, we say, well, this is a request from Firefox. We don't trust Firefox. First you get a secure browser, our hardened browser. So rather than sending the first page, passing them on to the application, we turn around and force download the hardened browser. That starts up on the client machine, gets installed, it's pretty small, it's only there for the session, starts up and loads the first page. Now we get the request back, this time from a hardened browser. Okay, perfect. Now we can allow the traffic to go back and forth. In order to get this functionality going, you don't really need a web application firewall. All you do need is a reverse proxy. Just so happens reverse proxy is the core functionality of most web application firewalls, certainly ours. So this is really handy, helps achieving this. The other thing is the support side. Friendly staff helping you along, you get lost. Maybe you have heard about the company Unblue. It's a Swiss company that provides, they basically invented something called co-browsing. They provide a software to do exactly this, and we integrated with them, so this whole system works seamlessly. The idea here is you use your online banking system, and every time you do this transaction, try to do this transaction to Hong Kong, something goes wrong and you get an error message. After 15 minutes of trying, you call up their support, and they say, well, no problem, just do it again, click on it once again, which you do. The server delivers the error message to your client. You see it in your browser, but it also goes to a specific server on the side. And now the support person, their office, can access the same content and see the same thing. Now you're talking to each other on the phone, and the support person sees the exactly same thing as you see, the same screen, and can help you along. But oh, sorry, yeah, you forgot to input the banking code. That's lacking there. If you put that in, it works. Depending on how you set it up, the support person may actually interact with the application themselves, or they're just sitting there and watching you do it. Again, in order to achieve co-browsing, you need a reverse proxy, which is included in the WAF. As I said in the beginning, airports are really complex systems where a lot of individual components work together to achieve overall a high level of security. It's police, customs, other private security companies, all the airlines, everybody works together. We think the same thing is possible in your web application environment. It's not really a vision, it's basically all there already. Upstream authentication is something, that's been around for a while. The idea of having a gate at the front. Once you pass it through it, you have access to all the applications behind. Custom filters. Yeah, you can write custom filters. There's even an SDK in our case. So you write 1 or 2 Java classes. The rest is done by our system. Declarative whitelisting allows, already today, is used in several applications where developers decide, well, we put out this form and for each field they define what kind of values are valid and which ones are not. Hardened browser enforcement, as well as co-browsing support, it's all there. So really, all it takes is take all those pieces, integrate them, and get a system that is really, really safe. That's all I had to say, and I see I was much quicker than when I rehearsed this thing, which will give you more time in the coffee break afterwards. But before I ask you my questions, now would be the time for you to ask me your questions.
About this hardened browser enforcement, how do you check whether the client is accessing with the hardened browser or not?
Well, we know from the way he accesses it, there's certain specific signatures and header files, header fields that come along, so we know it's a...
It's not making sure somebody's using Firefox and sending manipulated HTTP headers, for example. It's just
there is a way to figure it out by encrypting the headers first and only accepting specifically encrypted headers back.
How do I ensure as a user that nobody's co-browsing my session without having my permission?
Well, that's a very good question. And that's probably one we should ask Anlu. I don't really know how they do it. I just saw that basically to initiate the session, the user has to click on a button. So before the user actually opens a link and says, well, I accept that now co-browsing is going on, the traffic only goes directly from the web application to him and not via the co-browsing server.
For declarative whitelisting, is there any industry standard for such a thing, or is it only a new product?
We started out having it in our product. We called it ADAPS, which I have to admit I never really could memorize what it stands for. It's one of those acronyms. But that's basically just a set of tags that you can send along. We take that, we take the information that's in them, and we filter them out and let the rest out. So that's something that's pretty specific to our product. But in HTML5, and specifically in form 2.0, there is already something that can be used for this. So there are tags, there are attributes where you can use to define the valid content for fields, and we can process that as well. So if you want to use an old site, you need to adapt to our standard. If you have a HTML5 site, it's done.
You mentioned the possibility of creation of custom filters by writing Java classes like a true Java class.
Yeah.
But this has nothing to do with the ICAP interface.
Well, in the end, it uses the ICAP interface, but we wrote a little SDK so you don't need to bother about ICAP. You just write the filter classes and you hook them into our little framework, and then the ICAP traffic is done by us and you do the filtering.
Okay.
Any other questions?
It's the form field protection you have implemented. Is it also a part of this declarative whitelisting, or is that a different thing?
It's a slightly different thing where we pass, even if you don't use declarative whitelisting, if you don't use the system where your developers pass on additional information, we can protect your form a little bit by encrypting the form, encrypting information about the fields. So if anybody tries to send back additional fields, let's say, we figure that out because we know already what's in the signature of the form.
For the case where you don't know what the application is doing, is there some kind of learning or training mode of the application firewall? So you can say, now we have all the use cases, and it will be whitelist, the rest, drop it.
We don't have that.
Okay.
I hope we will have in the future. Right now we don't.
Because that's a lot of work to do with speculative whitelisting. That's
of course, yeah. I mean, that's pretty sophisticated, high level. Usually people start out, most of the time people also don't develop their own applications. I don't know, 60 or 70% of our customers, they put Microsoft SharePoint and Microsoft Exchange behind the network. And they just put it in, and there we have customized templates that work for those kind of applications. But if you want to go deeper into it and really develop your own applications and make the whole system as secure as possible, then probably you start first working with the filters in the front, and then eventually you get to the point where you use declarative whitelisting. Okay, then I have a couple of questions for you. You may start shaking. Ah, okay. Okay, question number one. Which kind of authentication ensures maximum security for your web applications? Authentication by the application, instant authentication, upstream authentication, or downstream authentication. You may vote now. If you're really shaking up and down, that's how it produces electricity. Well, yeah, 90% had it right. 10% had at least the stream authentication right the first time. Okay. Question number two. ICAP is a protocol used when implementing customized filtering, upstream authentication, declarative whitelisting, or enforced secure browsing. Filtering, 83%. Yeah, at least majority listen to what I was saying. It is actually the case that a lot of other things could be done using ICAP as well, just we don't use it for that. Declarative whitelisting protects image data, all data, forum posts, or media data. We don't do anything with the rest of the data with declarative whitelisting, because there we really say, how do form fields look and what kind of input do we accept? Last question, and then you're off for coffee. Which device in your network enables you to implement enforced secure browsing and co-browsing? Is it the network firewall, the load balancer, the router, or the reverse proxy? That would be the reverse proxy, correct. Well, 4 out of 4. Congratulations. Enjoy your coffee break, and thanks for your attention.
Thank you.